In this video, we're going to be looking at graphing polynomials, and within that graphing, we're going to be talking about the end behavior of polynomials. So some key things to keep in mind. With graphing, X-Intercepts means set y equal to 0, which you'll see on your screen to the left. You're going to take your equation and set it equal to 0. So pretty much the only thing we know by now is that you have to solve by factoring or quadratic formula. Quadratic formula only works if it's x squared. So X-Intercepts, you set the whole thing equal to 0, set y equal to 0. Y-Intercepts, you set x equal to 0. So it actually ends up being the constant if it's written in standard form. If it's written in factored form, you're going to have to plug in x equals 0, like we'll see in one of our later examples. With end behavior, this chart is in your notes. It's in OneNote, but just a reminder that the end behavior deals with what the leading coefficient, whether it's positive or negative, and then it also deals with whether the degree is even or odd. So we'll be looking at that in one of our examples as well. So here's our first example. The function is highlighted in yellow. It says identify the correct graph and the x and y intercepts of the following polynomial. So you'll see my function is g of x equals x minus 4, x plus 2, and 2 minus x. So the first thing I would recommend doing is figuring out the end behavior, and that's going to help me narrow down some graphs. So the end behavior depends on the leading coefficient and the degree. So the leading coefficient comes from the x terms. Now, I don't have to FOIL this thing out, but if I were to multiply all of the first terms, with the exception of this last one, this thing right here, the order is reversed. So if I were to rewrite that as negative x plus 2, I would take and multiply the negative x. So for my leading coefficient, I'm going to have x times negative x. So that's going to actually give me negative x cubed as my first term. Now, I don't care about all that other stuff. End behavior just deals with the leading term. So the leading coefficient in this thing is negative 1, and the degree is 3. So just based off my end behavior, a leading coefficient of negative and an odd degree means that my end behavior is going to be up on the left, down on the right. Now, you will see different notation, but the chart that we talked about in class just means up on the left, down on the right. So now I can already throw out some graphs. I can throw out that graph, and I can throw out that graph, because those two go the opposite direction. So I already have it narrowed down to 2 choices. Now to further narrow it down, I'm going to find my x and y intercepts. So your x-intercepts come from setting the whole function, or g of x, or y, all of those mean the same thing, set the thing equal to 0. So I've already written it down in the bottom left, so I'm going to set each piece equal to 0. Well, x minus 4, that's going to give me a y-intercept of 4. X plus 2 is going to give me is going to give me an x-intercept of negative 2, and 2 minus x is going to give me an x-intercept of 2. And I just set each one of those equal to 0. So from here, I have 3 x-intercepts. So now I should be able to narrow down my graph to just see which one of them has 3 x-intercepts. You'll see in that third graph, those are the 3 which look to be about where I'm thinking, negative 2, positive 2, and 4. So you're going to type those into Hawks. Now they want it as a point, so you'll have to do the point 4, 0, negative 2, 0, and 2, 0, and put commas in between all of those. The next one is the y-intercepts. Well, the y-intercepts, because it's not in standard form, I can't just use the constant. I have to plug in everywhere x equals 0, or you could multiply all that out and find the constant, but honestly, it's way easier to just plug in 0 for x. So I went ahead and filled it in. You'll see 0 filled in for x in the equation. So I have 0 minus 4 gives me negative 4. 0 plus 2 gives me 2. 2 minus 0 gives me 2. So I have negative 4 times 2 gives me negative 8. Negative 8 times 2 gives me negative 16. So that is my y-intercept. Again, you have to do it as a point. So it's 0, negative 16, which then confirms that that is indeed my correct graph. All right, so here's my second example. So I'm given a function and s of x. The first step says find the degree and the leading coefficient. Now, if you were to look at this quickly, you may say, okay, the degree and leading coefficient are negative 3x squared. However, that's not the leading term because I had to technically multiply everything out. So I take the first terms, negative 3x squared, x, and x. So my leading term is going to be negative 3x to the fourth, not just negative 3x squared. So now it's easier to find my degree and leading coefficient. My degree is 4, and my leading coefficient is negative 3. So the second part asks about the end behavior as x goes to positive and negative infinity. So this thing right here says as the function goes off to negative infinity in the x and as it goes off to positive infinity, tell me what it's doing. It's just another way of asking what's the end behavior, which has to do with my leading coefficient and my degree. So a even degree means it's either going up, up, or down, down. A negative leading coefficient means that my end behavior is going down to the left, down to the right. Now, Hawks wants it a little bit different. So they say as s of x goes to negative infinity, that's code word for left, what's happening to my graph? Well, we found right here that it's going down as it goes to the left. So that's negative infinity. The other one says what's happening as it goes to positive infinity. Well, that says as it goes to the right, what's happening? Our end behavior says it's going down as it goes to the right. So that gives me negative infinity for both of them.